Good day, my name is Koketso Ingrid Mango. Today I'll be doing a presentation on the influence of mathematics curriculum and curriculum materials with specific focus on textbooks, on mathematics teaching and learning. What is mathematics? People often mistake mathematics with just adding, subtracting, multiplying, and dividing numbers. But there's more to mathematics than just arithmetic skills. According to Department of Basic Education, mathematics is a language that uses symbols and notations to represent relationships in numbers, geometry, and graphics. It is a human activity that involves identifying, visualizing, and analyzing quantitative links between mathematical objects as well as between physical and social occurrences. That means that mathematics is a universal subject, understood differently and interpreted differently, but usually mean the same thing. Addition, subtraction, multiplication, and division have the same meaning in mathematics worldwide. For example, if someone asked you to multiply 3 by 4, one would repeatedly add 3's 4 times, while another would add 4's 3 times, but they both would end up with 12 as the answer. Both arrived at the same answer using different methods, and the interpretation from both would also be different due to how they analyzed and visualized the same problem. It's the same with the half-empty, half-full glass situation. We see things differently as well as in mathematics. Hence, it becomes a problem for teachers to teach methods of solving problems if we see the problem differently. Mathematics aids in the development of thought processes that improve accuracy, logical and critical reasoning, and problem-solving abilities that are necessary for decision-making. Your feelings towards mathematics do not matter because no matter who says, nobody goes a day without using mathematics to make decisions. Imagine a simple scenario of driving a car. You get to a traffic light and the light is amber. Whether you decide to quickly cross or slow down depends on the calculations you make at that time. And if they are accurate enough, then you cross safely. But if they are not, or somebody else miscalculate, then boom, an accident occurs. Probability takes place in an instant, and one never even think that they are applying mathematics at that time. Your decision making at that time was based on mathematical thought processing. The influence of mathematics curriculum. Ofoma and Bediako define curriculum as a program made up of 3 parts: a study program, an activity program, and a guidance program. Alebioso also and Bediako describe the curriculum as a tool that directs the operations of educational institutions. It serves as the means of disseminating information and other educational activities. As part of the curriculum implementation process, learners are assisted in gaining information or experience. All that means is that the curriculum is an official written document that assists teachers with lesson planning and how to impart that knowledge to learners. The CAPS is an official written curriculum document. Teachers prepare their lessons from the CAPS together with other curriculum materials, forming the intended curriculum. However, when in class, the curriculum becomes slightly different from the 2 above-mentioned curricula, which is then the implemented curriculum. The way in which learners understood the content is then the enacted curriculum. The modern definition of curriculum comprises the documented policy, which is the written curriculum, the teacher's lesson planning, which is the intended curriculum, and the actual implementation of curriculum-based tasks in the classroom, which are those enacted curriculum. These various meanings of curriculum unfolds in a series of sequential phases. This means that the curriculum is changed via interpretative and interactive procedures from both inside and between some of these phases. Between the written and intended phases, teachers modify the written curriculum into a format they think will be practical in the classroom by using their existing knowledge, viewpoints, and objectives. During the enactment phase, the teacher and the students work together to bring the curriculum to life, and in the process, produce something that is distinct from what might be found in the book's pages, the teacher's head, or the lesson plan. The modern definition of curriculum comprises the course of study, the method of instruction used in each course, the school guidance program, and the extracurricular activity schedule. The curriculum is not only about what takes place in the classroom. Take life skills, for instance. The curriculum specifies how much time is allocated for personal and social well-being, which is the theory part, then creative art, which is the practical, and lastly, the physical education, which you can never do in class or being inactive. It is therefore crucial to remember that learners are necessary for the implementation of the curriculum. As a result, the learners take center stage in this process of implementing the curriculum. Although a number of other factors, including the availability of resources and facilities, the instructor, the setting of the classroom, the school's culture and philosophies, instructional oversight, and assessment, also have an impact on curriculum implementation. That means that the experiences that a student has while following the guidance of the school make up the curriculum of the school. Educational systems curriculum is established and planned in accordance with societal needs. The curriculum is therefore dynamic, just like the society is. As a result, the curriculum frequently changes. In terms of modern education, the curriculum at the school is made up of all the experiences that a student has while being guided by the institution. The Curriculum and Assessment Policy Statement, that is your CAPS, the current curriculum statement for South Africa, is on par with mathematics curricula from other nations in terms of quality, scope, and depth. The CAPS has the potential to equip South African learners with 21st century skills and to adequately prepare them for the demands of the fourth industrial revolution, which emphasizes cyber-physical production system as advocated by the World Economic Forum, if it were to be implemented as it was conceptualized. Surprisingly, a large number of the 21st century talents and the talents necessary to succeed in the labor market of the fourth industrial revolution era are prominently featured in the CAPS as part of the main objective of the curriculum. So the CAPS, which is the current curriculum, is of great quality. The problem remains the implementation of the curriculum, the available resources, and professional development of teachers in terms of advancing their teaching skills, especially where mathematics is involved. Mathematics teaching requires the curriculum and instruction for teaching mathematics to adapt to meet the demands of the topic, the pupil, and the society in a changing environment. That means that the mathematics teacher must be close friends with Google because every now and then they have to keep up with the world and how to keep their teaching in context with the learning and the changing environment. We live in a world where shops no longer carry 2 cents as change when you buy cash. The example we make in class while teaching have to be relevant so learners will be able to visualize what is being taught and make connections. Teaching requires for teachers to have a broad range of knowledge in order to effectively teach mathematics. They must understand their pupils as learners and modify their instructional approaches in response to diverse experiences of their students. Teachers to create lessons that show pupils what they already know, what they've struggled grasping, and how to build more sophisticated mathematical understanding. We have to shy away from the fact that most of us want to teach, and because of that, we think of learners as empty vessels. But they're not empty vessels, are they? They have some knowledge, and they always bring that knowledge to class. As teachers, we have to open to understanding how they think, to a point of understanding the misconceptions they make or might make. Allow them to make mistakes so you can guide them in correcting those mistakes, but never assume that they have to learn the way you want them to learn, or they might just not learn anything at all and just nod whenever you ask if they understand something, just to get over and done with the lesson. In order to assist students' understanding of mathematics, teachers require to design engaging and helpful learning environments in the classroom. Additionally, teachers must design their lessons to reflect, inquire, work through issues, and debate their points of view. The best way to create a conducive learning environment is teaching learners through problem solving and allowing them to work in groups to come up with solutions to the problem at hand. It is like watching a TV show that starts with them showing you who the victim is and who the perpetrator is. And you have to work everything out to find reasons to dismiss everyone else who is not guilty of the crime and give reasons why the perpetrator is guilty and what his motive could have been. And the name of the show was Motives. One would need to apply different skills if they were given a problem and different solutions. The learners would then have to figure out which solution is true and how they can get to it and how to prove that it is indeed the correct solution. Lessons in mathematics are required to encourage conceptual thinking about mathematical concepts, the development of mathematical language so that students can express themselves mathematically, and the development of procedural competence so that students can use mathematical procedures effectively in both routine and problem-solving activities. Learners should indeed be taught about mathematical concepts and procedures, but that does not mean we have to teach learners shortcuts or solving problems. Such defies the curriculum that is trying to make sure these learners turn into problem solvers. They have to come up with those shortcuts themselves after understanding concepts and procedures. They have to figure out ways to solve certain problems in a quicker way, and they will once we enable them to understand why things are the way they are and how they work. Mathematics is like a puzzle. Give the child all the puzzle pieces and the final product, and let them figure out where to start and how to proceed. To my surprise, again in the movie, a child was able to solve the puzzle while it was upside down. So thinking for these learners does not assist them in any way. According to the Department of Basic Education, teachers in a learning-centered mathematics classroom should use assessment for learning. Assessment could be used in a way to check the progress of what the learner has learned thus far, not one exam that requires so much from learners. Provide clear explanations of concepts and procedures, address learners' errors and misconceptions, and also address gaps in learners' knowledge. Proper lesson planning will assist in clear explanations of concepts and procedures, and it will also aid you in thinking like those learners when you teach to such an extent of knowing the errors and misconceptions they might make. Through that, the gaps in the learner's knowledge will be closed. Make connections between different topics, provide opportunities for active learning, and select and design tasks that emphasize key mathematical ideas and mathematical ways of working. No topic in mathematics is an island of its own. If they're not connected, then one is a building block of another topic. Think of fractions. They start with simple examples like those of pizza. Then we end up talking about probability or shopping discounts. The topic always starts with fractions. Then we are talking decimals, ratios, percentages, and probabilities. Allow learners to connect these topics on their own so they will be able to interpret them. Learners should be able to represent scenarios they are trying to solve mathematically in a math class. In general, teachers should work to develop students' procedural fluency, which involves the ability to carry out procedures compliantly, accurately, efficiently, and appropriately. They have to be able to develop learner strategic competence, which is the ability to formulate, represent, and decide on appropriate strategies to solve mathematical problems and provide multisensory instruction. Mathematics learning requires learning mathematics with understanding to achieve mathematical proficiency. Students must actively acquire mathematical knowledge from their own experiences and past knowledge. Children may build up on their grasp of the mathematics they are learning to learn additional mathematics and utilize that mathematics to solve issues, which will enable them to become mathematically skilled, especially in a changing environment. The term mathematical proficiency describes what is required for anyone to successfully learn mathematics, despite the fact that no term can entirely encompass all the characteristics of expertise, competence, knowledge, and facility in mathematics. Conceptual comprehension, procedural fluency, strategic competence, adaptive thinking, and productive disposition are the 5 components or strengths that are perceived as constituting mathematical ability. These abilities indicate that someone understands and can do mathematics. The development of a learner's proficiency and knowledge in a number of methods occurs when they are encouraged to apply a variety of strategies, and this allows them to operate more confidently when performing mathematical operations. Learners should be given access to and freedom to experiment with a wide variety of calculation techniques. This will provide them the ability to determine for themselves which method is the most effective and/or which strategy they prefer to employ. It is important to emphasize and promote numerical strategies. Numeric recording effectiveness should also be promoted. For all activities intended to foster the development of mathematical number sense in the context of number and operations, formal numeric records of computation should be included. The long-term benefit of using strategies that use the structure of place value when recording numeric working from the start is that these strategies can more easily be generalized to bigger numbers in later years. Counting as an operation strategy should be actively discouraged, especially when they are inefficient, such as when working with large numbers. This will help to move learners away from the tallies, which represent counts, when they operate on numbers. The column method of recording numerical working is an efficient recording strategy. Alternative strategies are useful in addition to the column method because they highlight other aspects of numbers that also build learner number sense. Relationships between different methods of recording numeric calculations should be discussed, and this kind of discussion supports the development of conceptual understanding. Such discussions also promote the development of learners' reasoning abilities, which is the 4th dimension of the framework. If students are provided several diverse opportunities to develop their procedural fluency at the same time as they acquire their conceptual understanding, they will develop the capacity to work flexibly with numbers and complete operations efficiently. It is clear that CAPS places a strong emphasis on helping students improve their capacity to discuss and convey their ideas as well as solve challenges. Students will have the chance to make sense of mathematics, speak mathematics, develop fluency in fundamental mathematical operations, connect representation, and justify their thinking in a learning-centered mathematics classroom. Influence of mathematics textbooks. Textbooks are considered the most important teaching and learning tool because they outline the aims needed to be achieved by the end of the lesson as well as a chapter. They have an influence on how teachers plan their lessons. Therefore, they have a significant influence on how students learn in the classroom. They're regularly the major curricular materials used by students to acquire mathematics outside of the classroom. It is vital to give students access to 21st century learning through mathematics textbooks. Given the significance of both the textbooks and 21st century learning in mathematics teaching and learning. As you've said, the most frequently utilized resource in math education has always been textbooks. However, the majority of mathematics textbooks place more of an emphasis on exercises that emphasize routine procedures than they do on the development of concepts. Processes for choosing textbooks can be overwhelming. For the textbook to be distributed on a nationwide basis, a textbook must cover every subject from the curricula and standard of Department of Basic Education that explicitly establish list of permissible materials. Despite having supplemental information, many textbooks omit to address student thought progression or techniques. They usually skip over mathematical process description as well. Furthermore, students may become confused or distracted by decorative artwork that has little to do with the material in a textbook. Purposeful activities or exercises should be carefully chosen to ensure that they are fit for purpose and contribute meaningful to teaching. It must be stressed that the 4 dimensions of the mathematics teaching and learning frameworks are interdependent and that this interdependence should be reflected in textbooks. Activities should be structured to reflect the 4 dimensions in an integrated rather than a distinct way. Another issue is the development of instructors' abilities to obtain and utilize quality teaching resources. The depth and clarity of the conceptual development supported by the resources or the continuity of presentation of issues are typically not given enough attention by committee members. Instead, they frequently concentrate on trivial aspects like the way the materials look and if all of the objectives on a checklist have been met. In states and local districts with a significant number of stated special criteria, the issues caused by checklists are more acute. A program can be terminated if it fails to even meet a handful of these requirements. Curriculum interpretation, one of the main functions of textbooks, is to accurately and thoroughly reflect the curriculum so that reliance on the textbook does not compromise curriculum coverage. To make sure that ideas that logically go together are taught sequentially or as a unit. This will help students connect various mathematical ideas and increase their conceptual knowledge. Roles of the teacher's guide. The teacher's guide should emphasize the pedagogical skills required to develop all 4 interdependent dimensions of the mathematics teaching and learning framework for South Africa. In addition to providing answers to the activities and exercises in the learner's textbook. Implications of the curriculum on teaching and learning. Learners who possess conceptual understanding can view mathematics as a connected web of ideas. They ought to be able to articulate the connections between various ideas and draw parallels between ideas and associated practices. Learners who possess conceptual knowledge can apply concepts and defend their positions. These are methods used to perform mathematics. Mathematical operations must be carried out accurately and effectively by learners. Additionally, they must understand when to apply a specific technique. The curriculum has been designed to fit the annual teaching plan, which is a pace setter and allows less time to help students understand and teachers to teach concepts because it is a time chaser instead of allowing one to proceed once the concepts are fully grasped. Lots of students are left confused because we have to move with the ATP or else, like in my school, you get into trouble with the curriculum tracker. Students should be able to recognize, apply, and create their own solutions for resolving mathematical issues, justifying and elaborating on one's mathematical concepts and expressing them using mathematical language and symbols are all parts of reasoning. Deductive and inductive reasoning techniques are both used in mathematical reasoning. We have already mentioned that no topic in mathematics is an island of its own. The ideas should perfectly fit together like puzzle pieces. We cannot take a puzzle that doesn't fit in and try to force it in because it has the qualities we want. The textbooks usually come with a small print on the cover that says the textbook is CAPS aligned, which means that the curriculum in those textbooks do not deviate from CAPS but support it. For every textbook manufactured, there must be a teaching guide that accompanies it. I wish that was the case with the DBE books that are manufactured for schools. They do not have teachers' guides, and some concepts are not straightforward, yet the department wants them to be used as the primary resource for teaching and learning. However, when the concepts are unclear, there's no reference for them. And lastly, textbooks are frequently the primary resources for pupils learning mathematics outside of the classroom. Students can prepare for class by reading the textbook's content or working on the exercises offered in the textbook.